Thank you so much. This presentation reminded me of a guy that Kate and I know, Leif Percyfield, and he developed this little pilot program where it rains a certain amount. He programmed it to be whatever it was. The light bulb over his toilet lights up red, and that meant that he cannot flush, and that was connected to a weather station, right? Yeah, precipitation levels.
This is a great kind of link between our two, all of the presentations, I think, because the decision about whether to flush or not is valuable to know, if, for the consumer, I guess, of the sewer system. But the information that helps you make that decision is hyper local. So you couldn't necessarily look at the weather reports that are coming from a station at JFK and know, on Staten Island whether or not you should or should not be flushing. So the city is very large and weather systems are complex. And if whether or not your capacity is being approached in your sewer shed is the data kind of is it that educational component that is of interest to all of us here? Sorry, I had to jump in and say.
I have to put a plug in. If you're interested in the type of green infrastructure projects that Franco featured in his presentation, the New York City Soil and Water Conservation District, which is my agency, is hosting a bus tour of GI project sites in New York City on October 23rd. If you're interested in participating on the bus tour, come see me after or during lunch and I'll get you the information. So, here are some questions. Let's see, I have a question for you, Kate. Why can't DEP put up its own Weather in the Watershed website? Is there anybody from New York City DEP here today? Oh, we can see.
Yeah. I mean, really, if DEP would like to respond, I'll give my response. And that is that they're working on it. And actually, our weathershed information is we've been very open. All of our information is free and open to everybody. And DEP's been very interested in it. They're working with a different, basically, set of priorities, right? So my watershed, we're really focused on people who get in the water and getting them that information right away. In the type of information we want is, has there been a CSO somewhere on this water body within the last 3 days? And so we're trying to answer that question. And I believe DEP is working to create a citywide alert system that meets the regulatory environment, but it is also very accurate, and so that they're not, we can kind of over-report, but I think that's a challenge. That's a concern of DEP's. And Sri, would you like to actually? No, am I representing you?
You covered it.
Right. So we have, I'll say, we have been somewhat critical of the kind of coming short. We would like to see full reporting, so that's why we kind of went ahead and created our own system. But we're both, both on the community side and on the agency side, I think we're both faced with data gaps. So that's why we went ahead and did the fine resolution weather monitoring. And that's something that I would love to see the city do, and so that's why we demonstrated it.
The next question is, wait, this is not it, sorry. No, this is it. Okay, so this is a question for Franco. In an ideal world in New York City, with 50% of the 5 boroughs being paved, how much total could green infrastructure, percent-wise, change runoff in New York City?
Well, the answer is it depends, because when you look at the sewer system, so if you were to look at how much rain triggers a CSO in different parts of the city, you'd find that, as Kate was talking about, we have different CSO sheds, and different CSO sheds have different sensitivity to rainfall. So in one CSO shed, it might be, the pipes are sized such that one little bit more stormwater gets in and the thing overflows. In another part of the city, the sewer pipes may have been built anticipating greater development than actually occurred, or there may have been depopulation And so the sewer pipes proportionately relative to that land area may have the ability to convey more water to the wastewater treatment plant. So, you know, in those areas you may not, you know, it may take a little bit more stormwater for the CSO to be triggered. So, you know, it's really hard to generalize. And the other thing that I'll point out is that the sewer system is not sort of a very straightforward network of pipes where you can say this pipe goes to there, goes to there, goes to there, goes to the CSO. When you actually look at the way the pipes are configured, you know, there's more or less these pipes are all going together, but then there are some strange pipes that come in from here that connects this sewer shed to a whole other sewer shed that you didn't anticipate, and we don't know exactly. So it's modeling the sewer system and how it works is a very complex process. Also, I think, you know, there are spatial differences. So the land availability that you have for, let's say, something like bioswales in Manhattan is very different than the land area that you might have available for bioswales in sort of, you know, eastern Queens. So also the land, you know, sort of spatial differences in land use, you know, come into play. But, you know, what that sort of does is have, you know, from a design perspective, makes us think about, well, maybe certain ideas make more sense in certain parts of the city and other ideas make more sense in other parts of the city. So, you know, water conservation efforts where you have high population density and building scale water recycling you have at the Solaire building, for example, you know, may make a lot of sense in areas where you don't have a lot of space to build bioswales. In other places, it may be sort of easy to just knock off some of the stormwater by building the bioswales. So, you know, I think it's, we're optimistic that green infrastructure in the proportions that the city has set forth in the green infrastructure plan can have measurable impacts on water quality, but we're gonna, that's part of the adaptive management plan, is to be measuring this and to be demonstrating whether or not, you know, at this level of implementation we're getting to the goals that we all want.
Next question. I have actually a quick question for you, Susie. How did you distribute your survey?
Okay, I did this, I used a clustered random sampling. I wanted to make sure that I got people who were close to the canal and far away, but I also wanted to not just go to an environmental group and give it to them because that would be very biased. So I used census data and GIS to get a scale of how close or far people were to the canal, and I randomly chose census tracts that were close and far, and then within that I randomly chose addresses. So it's very random, which is good for a survey.
The next question for anybody who wants to answer is, in brownfields or other contaminated waterfront areas, are there any new technologies or ideas in use besides removal of soil, such as adding something? Sponge Park?
I think adding something could be called bioremediation. Is that maybe where that's going? So in the city, basically, it's development is kind of the clip of development usually drives what type of remediation happens. And so because the clip of development is quick, people typically opt to dig out contaminated soils, haul them away, and bring in clean fill. In organizations like New Tech Alliance and others in the city have become actually to be, there's kind of this whole soil building up community around composting that's, you know, the kind of the nexus of food and watershed issues. So soil quality, improving the city's soil quality in situ, using composting, using mycoremediation, which incorporates mushrooms, using phytoremediation, which incorporates plants. There's a whole kind of menu of options, using natural systems to treat soils on site. That is something that's of great interest, and actually we've done some work in Newtown Creek with mushrooms. The challenges there is that it's kind of we don't really have the brain trust that we have maybe around stormwater as focused on these technologies, and also that time thing is it takes time. It takes a different set of skills, and oftentimes people don't have access to that time or skill. So there's a lot of benefits to kind of incubating, no pun intended again, kind of incubating these technologies and that skill set in the city. So that's something that we're working on for Newtown Creek at least.
I'll just say, sort of speaking as a hydrologist, that we can't underestimate how complex it is to figure out what happens once water gets underneath the surface in the city. I mean, even if we had no buildings and we were just talking about, somewhere in the middle of Kansas, where you just have an agricultural field and the water goes in the ground, it's still difficult because soils are heterogeneous and flow processes underground are complex. So it's still difficult to sort of predict where things go underground. But then factor in, we've filled wetlands, we've added soils, we've removed soils, we've put in pipes, we've removed pipes, we've added buildings, we've removed buildings. This is why monitoring is such a key part of green infrastructure plans everywhere, is because a lot of these questions are to be resolved. Where is the water going once we send it underground? At what distances are pollutants that we might be either introducing in stormwater onto the surface or mobilizing that are already in situ in the soil? How far will they go? So there's been research in place in Europe, for example, on the sides of highways that have looked at, because they've been doing a lot of these things much longer in Europe than we have here, and they've looked at things like lead and zinc in stormwater. If you're sending that stormwater to the shoulder of the highway, how far does it move? And so there's been research that's encouraging that says that it, is all pretty much within a finite area that you can look at. But we're just sort of doing that type of research here, and so there's a lot more that we need to learn about what happens.
How are we doing for time, by the way?
We're pretty good.
Okay.
Okay, I just want to say one last thing. There's a kind of in the whole menu of green infrastructure interventions, there are a few that are really appropriate, I think, for that kind of sidestep that issue for industrial areas or formerly contaminated sites. And green roofs are great. They fit the building type in industrial zones, and they kind of lift up the stormwater management kind of away from the danger zone. But also, treatment wetlands that can actually get at contamination, and certain stormwater management interventions that are lined, maybe separated from deeper soils. I've seen all of those things in that have been implemented, and to kind of fit the technique to the land use is the thing.
I'm glad you brought that up. And one of the photos that I showed was this constructed wetland that we built in the Bronx near ABC Carpet Warehouse, and it was, I don't want to say it was a brownfield, but it was sort of unknown soil characteristics. I mean, we tested it, but it was so mixed up. And so, we're now looking at the value of the lined wetland. It's not replenishing the groundwater table there, but it is sort of attenuating pollutants that would otherwise be in the stormwater and go directly into the Bronx River. Yeah, I'm glad you brought that up because I didn't mention that. But there are things that we can do even in places where soils are sort of suspicious.
Somewhat related to this question, are there concerns that green infrastructure accumulates non-point source pollution?
Sure. I've done a lot of monitoring, not in New York City, but in Florida, of green infrastructure, and monitoring is very important, and especially for phytoremediation, plant selection is very important. There's some plants that are able to actually denature a pollutant, and there are some plants that are just going to hold it, and when that plant dies, it's going to break down and the pollutant could be re-released. So when putting in projects like this, it's really important to know what kind of plants you're selecting, and if you are selecting those that are going to hold a pollutant, that you have a plan to go in there and get those plants out and treat them properly before they start to decay and re-release pollutants. This can be nutrients, which may not be that much of a concern, but it can also be a concern for heavy metals.
I'll just say, I think, we're working on this right now. A lot of research is going on in the city looking at what happens, in fact, some of the research that's going on at CCNY, at North Cuba City College, and what Tatiana is doing is looking at sort of what's happening to these soils in time. And some of the work that we found at that Queen site that I showed was actually quite interesting. That we have sort of samplers underneath the green street, and we have samplers of the stormwater, so we know what's coming in and we know what's coming out. And actually, some of the constituents change in sort of ways that you wouldn't expect. So what's coming out of the bottom, maybe because of the type of soils that we're putting in, maybe has more nutrients than what's coming in from the stormwater. So you're adding stormwater, but it's causing nutrients that are in the soil to come out and move into the groundwater. Is that a problem? Probably not, but at the concentrations that we're seeing there. But I think, though, to say even if pollutants are gradually building up in these green infrastructure facilities, we're not going to have completely toxic conditions tomorrow. We may have sort of gradual attenuation and then gradually the need to change those soils at some point in the future. But that's a whole lot better because we know where the green infrastructure sites are than just sending these things out in the estuary. And now we have legacy sediments on the bottom of the river that are really difficult to remove and maybe never will be removed and these kinds of things. So it's, even if that is an issue, maintenance of these sites going forward is going to be necessary. It's not, green infrastructure is not, we're not creating a passive system. It's still a heavily managed system. We're just using natural plants and soils to do some of the things that we could otherwise do with really expensive machines.
Okay, one more question. Do we have time for one more? Okay. The questioner says, I heard that Newtown Creek has been the catch of an oil spill, slow and persistent, that exceeds that of the Valdez oil spill. Where is it from? Where is it going? What is the current status?
Oh man.
Loaded question.
The last question is a doozy. So the slide that I showed of the tank farm, the historic, that's where it came from. So it came from, basically the Standard Oil kind of started an oil site at that property on Newtown Creek, which is in Greenpoint. And then it's been successively operated by different oil companies. And today, ExxonMobil is undertaking the remediation of the oil spill in Greenpoint. And basically, yes, it's larger than Exxon Valdez. It goes, if you're familiar with Greenpoint, the plume extends from Newtown Creek behind McGorrick Park all the way beyond the BQE, if you're familiar with that geography. It's a large area, in summary, if you're not familiar with that area. And the way it was, quote unquote, discovered, I say quotes because it was known through several sources for many decades. The way it was discovered was basically seepage into Newtown Creek, which made it visible. The oil is resting on basically the water table, the groundwater. And it's being remediated now. It's slowly pumped out. That oil is refined and sold. And it's been the subject of litigation from the topic of its cleanup is a whole presentation unto itself. But Riverkeeper, as well as the state AG, who was Cuomo at the time, essentially pressed ExxonMobil to enhance their remediation, and that resulted in a settlement that's actually now being offered to the community as an environmental benefits kind of funding. I believe the amount is $19.5 million, which is a large sum, but considering the scale of the project and the scale of the remediation operation, it's that's an interesting local issue. What was the rest of the question? Did that even attempt to throw a lasso around?
Where is it going?
And where is it going? Well, so the oil is being pumped out and sold. That's where it's going, and it's going slowly, but it is going. I'm not sure what the amount of the oil, what fraction of it is actually out of the soil now, but we actually just had a Newtown Creek Lines meeting on Monday where this came up. Once the soil, because it's in the water, in the groundwater, once it's pumped out, then we can safely assume that there will be a certain amount of residual material kind of soaked into as weather happens and seasons change, the groundwater moves in the soil, and in the process of extracting it, there will be an imprint of the oil product in the soil, and so that's kind of a persistent long-term issue. Today, it is being on the creek. the seepage into the creek has been significantly controlled. However, we've actually seen seepage from other portions of the creek, from the Queen side. And so the issue of oil around Newtown Creek is, one for my generation, I think, hopefully not the next one as well.
Okay, there was one more question, but I think it is a better question for the 11:40 session, so I'm going to give it to Gabriela, and we'll be sure to address it in that session. So, that's it for this panel, so please give the panelists a round of applause.